Hello, I'm Mr. Bob, and welcome to my Geometry Review video series. This video covers Chapter 12, Section 13, titled Rotations. By the end of this video, you will have reviewed recent lessons on drawing and identifying rotation images. You will review the real-world problem and review compositions of rotations. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to the channel if you find this video to be helpful. Thank you. Okay, to start off, we'll look at a definition, and that's a rotation. In general, a rotation of x degrees about point R is a transformation for which the following are true. First, the image of R is itself, that is, R prime equals R. So the image of R is itself. R prime equals R. And for any point V, comma, R V prime, and the measure of angle VRV prime is equal to X. We'll see more of that and looking at that during the review. Okay, objective 1, drawing and identifying rotation images. To describe a rotation, you need to know the center of rotation, which is a point, and the angle of rotation is a positive number of degrees, and whether the rotation is clockwise or counterclockwise. But in these reviews, unless otherwise stated, the rotations are going to be always counterclockwise. But so here we're going to talk about it. In general, a rotation of x degrees about a point R is a transformation for which the following are true. So what are we talking about? Looking at here to the right, where R is where we're going to rotate about. This is the point we're rotating about, R. And we talk about any point V, and we're going to move V along this arc, and as we're moving it, these two lines, the distance from R to V, or R primed, which is the new position at any time as we're traveling, which is always itself, these distances are equal, okay? So we're going to move V to V prime along an angle of X. So it says the image of R is itself. So as you see, here's R right here, and its image is the same point. The image of R is itself. So that is R prime equals R. Never moves. And for any point V, that's here, any point V, could be any point V along that got selected. Doesn't matter where V is selected. RV prime, the distance RV prime, this distance here, RV prime, and RV, which is the bottom leg here, RV, and the measure of angle VRV prime, I'm going to change colors, VRV prime, that angle right there, the measure of that angle is equal to X. That's how far we're rotating. Okay? Okay, example 1, drawing a rotation image. So we're going to take this image here on the right-hand side, this LOB, this triangle, LOB, and a point C. You see, well, here is C, and we got these vertexes right here, vertices, L, B, and O. And we're going to rotate this triangle around the point C. So when we get to step 1, so it says draw an image, before that it says draw the image of triangle LOB for a 100-degree rotation about C. So now you see we're going to rotate this triangle around. It's going to swing in a kind of an arc, right? It's going to go around the circle. Okay, in a curve, if you will. So step 1, use a protractor to draw a 100-degree angle with vertex at C and a side CO. So what they're saying is we're gonna rotate about an angle that we're gonna draw this. Let's do this. We're gonna draw the line here, CO, from C to O. You draw a line from C to O, and then you put your protractor on this line with the center on C, and come over and you strike off a 100-degree angle. You put a point on your paper, and then you draw that line. Draw it longer than probably needs to be because you're going to have to cut off you're going to measure it. So now you're going to have that line drawn from C to that point you put on the paper based on the 100-degree angle from OC. Now you've done the first one. Now what you do is you use a compass. Step 2. Use a compass to construct CO prime congruent to CO. These segments, right? Segment CO prime congruent with CO. So how do you do that? You put your compass pin here and you stretch out and you measure right out here, and then you come rotate your compass around to the line, and you're going to strike an arc. Now you have the length of C and the position of the new C. So when you're all done rotating it, your new C is going to be right here. Okay? So that's the easy part. Now it says locate B prime and L prime in a similar manner. And then it says finally draw angle LOB. I don't think so. I think it should be triangle. It should be triangle. I'll change that later. So if you watch a video, you know this is going to switch. This will be a triangle when I'm done. Anyways, so it says locate B prime, L prime in a similar manner, and then draw the triangle. So how do you do that? So then it says basically you're going to go from C, because where everything's rotating from C, you're going to go from C and you're going to draw this red line going down here to L. Okay. Now from C to L, you're going to put your protractor on this line with the center of the protractor on C, and then you're going to come over and you're going to locate around going counterclockwise till you get to 100 degrees. Okay. And then you're going to stop, and then you're going to draw your line, your new CL prime. It's going to be a long line. It goes as long as you want. Then you take your compass, measure from C to L, and then come over here and strike off on the line. Boom, your arc right there. That becomes your new L. So now you have your C or your O prime, and you have your L prime. Now you're going to do B. So you go from C, go back to your diagram, go from C, draw a line down to B, set up your protractor so that the center is on C, and you can read down here and strike out 100 degrees. So you're going to go a circle all the way around, and you're going to get to 100 degrees. And then you don't have to draw the line, but you probably should. You'll draw a line, and then you're going to measure from C to B. Right here, C to B. And then you're going to come over here and you're going to strike off up here in the upper corner, right up here. You're going to strike off the C, B prime, and you can put your dot right there. So now you have O prime, L prime, and B prime. So the last thing it says is draw LOB. So then what you're going to do is you're just going to come in here and you're going to draw LO. And here's LO, here's LB. Hopefully there'll be better lines than mine. And that's how you rotate it. Now this triangle is now rotated 100 degrees. Okay? Okay, example 1, check your understanding. We'd like you to pause the video and just try to do one of these yourself. Here's the triangle. It doesn't matter what the triangle looks like. And you can draw a point. And then just use your techniques. We're going to draw the line from C to O, right? And strike off your angle. And what do they want? They want draw the same thing like we did in example 1 above, and a 45-degree rotation about point B. Instead of rotating about point O, we're going to rotate, not O, instead of rotating around point C, we're going to rotate around point B. And the only reason that C is in the picture is because I used the same photograph in here as I did in the other one, but in theory, this C doesn't exist. Okay? I should have blanked it out. So there we are. So go ahead and stop it and try yourself. And when you come back, I'll show you what it should look like, I guess. Okay. Okay. So as you know, you're drawing a 45-degree rotation about B and label the vertices of the image. So as you see, we started off, this triangle here was your first, this is the pre-image triangle, right? L, O, and B, the pre-image triangle. And here's B down here. They want you to rotate 45 degrees around B. So we're going to take this. So what did you do? You took and you drew a line from, well, you already have your line, right? So you take and you from this line, from the edge over here, you take and put your protractor at B, go out a distance, and then go around the protractor till you find 45 degrees. And it's going to be like, say, somewhere, I'm going to say maybe it's way out here is where you mark on your protractor. So then you're going to come out and you're going to measure the distance from O to B, and you'd measure that with your compass, and then you take your from point B, and then here's your line going out. You made it extra long, and you're going to strike. Oops, I'll erase that. I missed. I need to try that again. I can't get it. Anyway, so you strike off your distance, and then you draw your line. You draw your line along, along here. So then you do the same thing with L. You take and you put your compass here at B. You look out. You look. You look around your not your compass, your protractor, and you move around, and then you find 45 degrees, and you mark a point, and then from there you draw your line, your new line, right? And then you measure the distance of L with your compass, and then you strike off. Oh, that was a better strike. A strike off the length of L prime. Now that you've got that, you can draw. You've got your lines drawn in, okay, and now you can draw from O prime to L prime, and you can get your other leg of your triangle. I hope that was clear enough with all my little scribble marks and stuff. Okay. Okay, example 2, identify a rotation image. So you can use what you know about regular polygons to identify images for a given angle of rotation. Regular pentagon, P-E-N-T-A, penta, is divided into 5 congruent triangles. Here's our P-E-N-T-A, right? Oh, where's my, there it is, P-E-N-T-A. That's our our polygon, which is a pentagon. Okay, and is divided into 5 congruent triangles, and you see them 1, 2, 3, all these triangles. So now you're up to speed in what we're looking at: a pentagon, 5 angles, 5 lines, 5 radii. Okay, and the letters P, E, N, T, and A. So it says name the image of E. Now they want you to find the image of E for a rotation of 72 degrees about X. Well, this rotation is about the center point, and they want to know the image of E. That means that E is the pre-image, right? So, and we're going to rotate 72 degrees. Well, how far? What is the distance between what's the angle here? What are these 5 angles? Those 5 angles are 72 degrees each. And right here in the formula, 360 degrees divided by 5 is 72. So they want you to find the image of E. We know the pre-image of E is right here. That's E. For a rotation of 72 degrees about X. Well, 72 degrees about X is over here. So P is the image of E. E is the pre-image. P is the image. We started with the pre-image. You end up where you ended up with is now the image. And we moved 72 degrees about X. Okay, so P is the image of E. So now this, in problem B, name the image of P for a 216 degree rotation about X. Well, we're going to start They want to name the image of P. Not the image P, but the image of it. So that means that P is the pre-image. Here we are, the pre-image. Okay, 260-degree rotation. 72 goes around 3, right? 216 degrees. So 72 times 3 is 216. So what is, when we're looking at the diagram here now, what is the image of P? Well, N is the image of P. Here's our N right here. We came around all these degrees, went 72 all the way around. What's 72? Was it 144? And then 216. Okay? Okay, example 2, check your understanding. So they'd like you to try this on your own. So why don't we go ahead and pause the video and give it a shot. Then when you come back, we'll take a look. Okay, so I'm assuming you've taken that and take a look at it. So let's see what we can come up with. Name the image of T for a 144-degree rotation about X. So the image of T is not T, right? It's the image of it. So that means after a 144-degree rotation. So based on the previous slide, we know that what? The angle of rotation for each segment is what? It's 72 degrees, right? And 144 degrees is 72 times 2 is equal to 144. Okay, so now we've got that. So they want the image of T for 144 degrees. Well, here's T right here. And we're going to go 144 degrees. Well, that means 2 segments. So we're going to go T. We're going to skip N, so to speak, and come right around here to E. And there's our 144-degree rotation. And it's counterclockwise because we said that all rotations are counterclockwise in our reviews here. Okay, everybody get that? 2 segments, 144 degrees. Boom. T, the image of T. It says for name the image of T. The image of T is E. Or it could be T primed if we didn't have these letters on it, right? If it was T, it could have been T prime. Could have been the image, but right now we have a letter there for it, so we know what the image is, and its name is E, excuse me. Okay, example 3, a real world problem. Native American art, or Native American Indian art. You can find circular designs with rotational images in some types of Native American art. In the design pictured, find the angle of rotation about C, and I'll point it out if you can't see it, that maps Q to X. Okay? Find the angle of rotation that maps Q to X. That means so that Q would be the pre-image, if you will, X would be the image, but we're going to just map Q to X. So it says the 8-pointed star in this design divides a circle into 8 congruent parts. 360 divided by 8 is 45. So each part has a 45-degree central angle. The angle of rotation that maps Q to X is 5 times 45, or 225 degrees. So if you look here, here is the C where they're rotating right in the middle here. Here's Q over here, and they're going to rotate all the way around the circle over here to X. Well, if you look straight through, if you just draw your line right straight through the center, oops, I'm going down. That's a little better, I guess. That's the diameter. Hopefully, you'll see the diameter. Then you can see that one more angle farther gives us X. So 1, 2, 3, 4, 5. So that's 225-degree mapping, or if you will, of Q to X. Okay, in the design here, we're talking about find the angle of rotation about C that maps Q to M. Well, just like we did it in the example, we mapped Q to X. Now we're going to map Q to M, and what they're looking to find the angle of rotation. How far is it? So Go ahead and pause the video, try figure it out, and come on back, and we'll work on it together. Okay, I think you've paused it and you're back, so we can look at it. So we're going to go from Q to M, and we know now from the previous example that it's 360 divided by 8 is equal to 45, right? So each one of these steps each one of these segments is 45 degrees. So we're going to go from Q on to 3 to M. So 45 plus 45 is 90, right? Plus another 45 is what? So 45 times 3 is equal to 135. 135 degrees. So from here around is 135 degrees. And we looked at the image, the circular image, the design, and looked at what's going on in the design, and we can instantly recognize distances between these segments. Okay. Okay, example 4, a compositions of rotations. A composition of rotations about the same point is itself a rotation about that point. To sketch the image, add the angles of rotation to find the total rotation. Okay, so what do they want you to do? What is that really saying here? So we're going to, a composition of rotations is you rotate an object a certain amount, and then say in this case it's going to be 30 degrees, and then you're going to rotate it again 30 more degrees, 60 degrees. Well, if I move something 30 degrees and then move it 60 degrees, that's the same as rotating it at 90 degrees because you add the two together. So it says that right here. It says, draw the image of the kite at the right for the composition of a 30-degree rotation and a 60-degree rotation, both about point K. So the total rotation is, as we just said, 90 degrees. Draw the kite, locate the image points of the vertices for a 90-degree rotation. Use the image point to sketch the entire image. Well, so what they're saying about doing is you've drawn this image, this K image, this image first, one from up here. You've drawn that image, and that's right here now. So what we're going to do now is we're going to rotate about K 90 degrees. Well, you can pick either one of these segments right here. It doesn't matter which one you do. If you pick this segment here, you're going to rotate. Okay, you're going to put your compass here on K, and you're going to go ahead and strike out a 90-degree angle. It's just going to come over and bring you somewhere over here. Okay, and then you can measure with your compass like we did before. You go from K to the outside edge of this line, this segment, and you can strike it off on your, it's going to go up here. You can strike it off. Now you've got the length of that segment. Now you can do it with this one. Put your compass center, not your compass, sorry, your protractor center here. Stretch out to the right, measure out 90 degrees, which brings you over here somewhere to this point. So now you can draw this line longer than you need to, because you're going to then strike the length of this segment here, from here to here. You're going to measure that, and then you're going to strike it out on this line over here. And that's going to give you this segment here and this segment here. Now, in order to draw the center, you can bisect this angle. And once you do that, I'm not going to bisect it, but you'd end up with having a line, down the center here. And then you would go here and strike the center of this for a length, and then you'd strike that length out here. And now you can draw all your segments necessary. Okay? Does it say anything else? Nope. Use the image point to sketch the entire image. So this is it right here. We just drew a line. We took one line. We measured off 90 degrees. We arced off with our compass the length of that first line. Then we did the same with the second line. Took our protractor, marked out 90 degrees, same as before. Strike the length. Then to make it exact, we had to do an angle bisector. We had to draw the angle bisector and then mark off the length to get the top of that kite if we're going to draw the image perfectly. Okay, example 4, check your understanding. Draw the kite at the right. We've seen this kite before. Then draw its image for a composition of two 90-degree rotations about point K. So I'll wait for you. Stop, pause the video, and then when you're back, we'll take a look at it. Okay? Have you got that? Okay, good. So let's take a look at this. Um, now that you're all back. Uh, so what this is, it's a composition. It says two 90-degree rotations. So two 90-degree rotations gives us what? So we're going from 90 degrees times 2 is 180 degrees. Well, that's a straight line, right? 180 degrees. So I think the interesting thing we can do here is I'm just going to draw right on this, on the dark section. I'm not going to worry about a white pad to draw on or anything. So what we want to do is we want to rotate this image. So what's it going to look like when all is said and done? If I rotate from point K, and we rotate and call this the baseline right here, we're going to go 180 degrees rotation. 90, going to go up here to 90, and then we're going to go back down over here to 180. So that means we're just going to, if I can draw it, we're just going to continue the line straight out. And if this goes around 180 degrees to form a straight line there, this one's going to go 180 degrees. If you took your protractor, you just end up with a straight line out like this. Obviously, it's not perfect, but you get the idea. And then, of course, if we do the bisector, we're going to somehow get out here, and then you're going to end up drawing kind of like that, right? So that is a rotation. This is supposed to be, I wish I could have done that a little better, straight line out like that. Maybe that's more like it. Should I redraw it? Should I give it another shot? Let's see if I can, let's see what we can do. Let's do it again. Okay, get that squiggly line off. Get that one off. We don't need that. So now we're just going to go back and pick this. And we're going to try and go a little, maybe I can change my arm location and draw it. I don't know. I'm going to go from out to here, say. Okay. And for this one, I'm going to go out to here. And then that's going to draw. And then put the bisector in. It's going to give us a point out here. We're going to draw the kite. I think you get the picture. This is supposed to have been a straight line. I still can't draw that straight line. Keep trying, huh? Is it worth it? Maybe it's worth it. Let me draw one more time. Oh, I wish I had better software to draw this with. So the line is going to go maybe to here. And this line is going to go to here. That one's pretty good. And then we'll draw the kite top. I think you get the picture. I'm going to erase this. I'm still looking for some software that I can do this with. And we're going to draw that line one more time. Kind of like that. It's closer to the image, but you get the idea. It's a rotation of two 90-degree rotations ends up being 180 degrees. Well, in this case, they're just straight lines. Maybe not as straight as they could have been, but I think you get the picture.